Hello, my name is Andy Hall and I'm a certified CAMWorks support engineer here at GoEngineer, and this is the third part of my continuing video series on 3-axis machining. And in this lesson we're going to combine some of the 2.5-axis features with the 3-axis. For starters, you see this part, we have some pockets, some tapped holes, some countersunk holes, and then this swoopy surface here. And so to get started, we'll just go ahead and enable our extract machinable features. This is just finding all the features it can. And you notice it found the this pocket, counterbore holes, and then this threaded holes, which tapped holes. We're just going to go ahead and finish up programming with this with our, just as we would any 2.5-axis part. We have a rough mill, and maybe that's not the strategy we want, so I'll go ahead and modify this, and we'll just go ahead and do a pocket out. We're running with a 1/4-inch end mill. That'll be fine. Maybe plunge in a little bit less, and then I'll go ahead and generate that. For our next one is, since we're all running this 1/8-inch tool, we might want to reorder our tool paths so we're sort of optimizing our tool changes. So that looks pretty good for that. I'm going to go ahead and insert my 3-axis feature, my multi-surface feature. Once again, we do select all and associate. And as I explained earlier in the earlier lessons, these are just pretty much out-of-the-box strategies as the approach of how we want to machine this. We can always modify this and add to this list through the technology database. So I'm going to just go ahead and let it remain as the default strategy, and I'll insert it and right-click on this to generate the operation plan, and the associated operations come off of that. So for starters, we're going to just do an area clearance, and I'm just going to select a smaller tool, because this one of course defaults to a 750 flat end mill, and we'll just start out with something smaller. Change some of the let's see, we're going pocket out. That looks good. We'll just leave that there, and now if we remember from before, we can insert a contain area to contain this, and I'll do a convert to loop, select this edge, and it'll select all the edges there. And I'll change this to an on-center tool condition so we make sure we get all the way up there, so the tool's allowed to go up there. And I'll just go ahead and generate my tool path. It might not be too important at this point because the tool's going to go there anyway. It's just a rough cut, but it's just good to know how to do that. Looks like we may have to, let's see, let's just set this something smaller so we get more levels. Now for the next one, just a couple of tricks on this pattern project. First of all, I'm going to change to a smaller tool. I have my filter on, and I'll select a 1/4-inch tool. In our pattern, we're just going to have this go 45 degrees. We'll make it stay down. And before we generate our tool path, we're going to do a control copy. We want to do the same contain area. So I'll control, drag, and drop, and generate my tool path. Again, just from right-clicking, generate tool path. And you'll see we got a nice even tool path going at 45 degrees to the axis. Now one thing you'll notice is how the tool goes up and over, and sort of, you see it there, up and over. On this example, we might just want it to go straight up and maybe exit the part and then come back over and then go down. So to do that, this is a nice little trick. First thing we're going to do is we're going to do a tangent extension and maybe do a 1/4-inch extension. We'll hit OK. We'll suspend this rebuild, so I'll just hit no so it doesn't rebuild the tool path, because we want to modify our contain area. We'll want to make that just up 2, so the tool diameter is going up 2. I'll hit finish, hit yes, and let it generate. And you can see what the tool path is now doing. It's just going straight up, over, and down. So that's a nice way to make a tool path like this. It makes it nice and clean. Of course, we might want to even come back and initiate our cross machining on something like this. So I select this cross machine to standard. Hit OK. Let it generate. Okay, the last thing we'll do is we're going to come in with just a little pencil mill and clean up this area down here. And so to do that, I'm going to right click, and you can right click on any of these operations. And we get to this option, Insert 3-Axis Mill Operation. I select on that, and then we have this operation called Pencil Mill, which essentially, as this image here shows, it's just like you imagine a cutter just going and tracing as a pencil in certain areas. So I'm going to go ahead and insert this and just tweak with some of the parameters. First of all, we're going to want a different tool. So I have an 1/8 inch diameter cutter that I'm going to use to come around here. And we're just going to play around with some of these settings here and make it a little bit different horizontal and vertical cut amounts. And then maybe set that. Looks everything's good. I'll hit OK, close, and go ahead and generate it. Once that generates, we'll see that it's going to try to cut pretty much everything. And the reason that is because, of course, we don't have a contain area, but that's easily remedied by a control drag and drop of these existing contain areas. And then I'll generate my tool path, and it'll contain everything in here. So we're getting just our pencil mill just inside there to clean up that little radius down there. So now we can go, of course, simulate it, run it on turbo mode, and we can get the results of what we're seeing. This has been a GoEngineer quick tip. Stay tuned for more. Anyway, thanks.